Hi everybody, this video will cover the first part of the first section in Chapter 7. And here we're going to talk about rational expressions, and we're going to look at the restrictions on rational expressions or variable restrictions on rational expressions, i.e. what values must be excluded when we have a rational expression. Well, what is a rational function? That should have said rational function, not rational functional. Well, let's let p of x and q of x be polynomial expressions, or polynomial functions. Basically the functions that we've talked about in Chapter 6, polynomials. Then, the ratio of p and q is a rational function. So basically a rational function is nothing more than a ratio of two polynomial expressions, and that's it. Okay, one of the cool things about rational functions is that they can make some really, really funky graphs. Like, check this sucker out right here. We have what almost looks like a parabola. We have this line going, we have a hyperbola here, and then another hyperbola here. So this is a pretty funky graph. Matter of fact, this graph has more shape than any other graph that we have seen so far in this particular course. And also notice that how when x gets really, really large, this graph behaves like a line. And if you excuse my drawing, well, here is sort of that line. Okay, we would actually call that an oblique asymptote. And also notice that the graph gets very, very tall, but theoretically never really touches this particular line right here, or this vertical line right here, and this vertical line right here, and we actually call these vertical lines horizontal asymptotes. Now, do you need to worry about that? The answer is no, you don't. But what you need to worry about is that if you notice that this line, that as we get closer to x equals minus 5 here, that is, trust me, that is x equals minus 5, that this particular graph, or that this graph is getting very, very large and is approaching infinity. And if it gets so high that it will actually reach infinity if it was part of the number system, but it's not, so it turns out that this function is undefined here. Similarly, where this graph also explodes, which by the way is around where x is equal to positive 3, it turns out that this function is not defined at x is equal to 3. And the purpose of this particular lesson, or this video, is to talk about how to find those values of x where this function would be undefined. And when does that occur? Whenever the denominator here is equal to 0. Okay, and what do we call the denominator? Well, we call it q of x. So what we want to do in this particular lesson is find all those values of x where q of x is equal to 0, because for those values, this function is undefined. Okay, to talk about this more, just remember that if we let a be any non-zero number, say, I don't know, 2, okay, and if we divide 2 by 0, what do we get? Well, we get nothing. We get something that is undefined. Technically, we could say that 2 divided by 0 is infinity. However, infinity is not a member of the real number system, and since it isn't, we would say that this would be undefined. Matter of fact, if you took your calculator and you did 2 divided by 0, it would give you a divide by 0 error because you can't divide by 0. Okay, well, this concept also applies for rational expressions. As a consequence, the ratio of p of x to q of x is undefined whenever q of x is equal to 0. And as a consequence, we need to exclude those values of x. To bring that point, just to be redundant about that again, the denominator of a rational expression can never be 0. Q of x is not allowed to be 0 because division by 0 is undefined. So we are going to want to find all values where q of x is equal to 0 and exclude them. So we want to exclude all x's where q of x is equal to 0. And that's what we want to do for this entire class. And that is basically the subject of this entire video. Okay, so that actually brings us to our first example. And this is perhaps the most basic rational function, is the polynomial 1 divided by the polynomial x. And if you plotted it, it would look something like this, if you pardon my pathetic excuse for drawing. It would look like you have a hyperbola going like that, and then a hyperbola going like this. Like I said, my drawing kind of stinks. And then what you can, and once again, what we want to do is find all those values of x where the denominator here is equal to 0. When does that occur? That occurs when x is equal to 0. This is the value of x that we need to restrict for this rational equation because that's the value of x for the denominator is equal to 0. Okay, so let's go to our next example. And this one is the ratio of 5 to 3x minus 1. Once again, we want to find the restricted values of x for this rational equation. The restricted values of x are all values of x that satisfy the equation 3x minus 1 is equal to 0. When does that occur? Well, subtract adding 1 to both sides. That occurs when 3x is equal to 1 or when x is equal to 1/3. This is the value of x that must be restricted. And notice to actually do this, we need to go back to what we learned in Chapter 2 to address to solve this problem. Okay, moving on. Here, we want to find the values of x, if any, that need to be restricted from this rational equation. Well, that occurs whenever the denominator is equal to 0, or when x squared minus 5x minus 6 is equal to 0. Now notice we are always focusing on the denominator. The restricted values of x have absolutely nothing to do with the numerator. Okay, it's all about the denominator, or as I said in class, it's all about the base, about the base, about the base, no treble. Okay, coming back to here, so we need to find all values of x where this is equal to 0. Well, notice that this is solving a quadratic equation. Okay, this is basically 6.6. Notice we have a quadratic expression where the leading coefficient is equal to 1. So this is also a 6.2 type problem. And for that, we need to find factors of -6 that sum to -5. And those two factors would be 1 and -6. 1 times -6 is -6. 1 plus -6 is -5. As a consequence, we can write this as x plus the product of x plus 1 and x minus 6. Now, using our zero factor property, we know that the two values equal to 0. I'm sorry. Now, using our zero factor property, we know that this will be true whenever this factor, x plus 1, is equal to 0, or when the other factor, x minus 6, is equal to 0. Of course, the former occurs when x is equal to -1. The latter occurs when x is equal to 6. And these are the two values of x that must be excluded from this rational expression. Okay, example 4. Here we had to find the values of x that are restricted for this rational expression. Once again, that will occur whenever x squared plus 36 is equal to 0. Okay? Well, that can only occur when x squared is equal to -36. However, whenever you take a number and square it, it will always be a positive number. Furthermore, if I took the square root of x, I would have x is equal to the square root of -36, and the square root of -6 does not map to a real number. So as a consequence, there is no value of x that needs to be excluded. So there are no restrictions. Okay, for example 5, we have this ungodly number, x to the 213 plus 4 divided by 86.5481864x. Okay, we want to find out which values of x must be restricted from this rational expression. Well, that occurs whenever 86.5481864x is equal to 0. When does that occur? Well, that occurs when x is equal to 0. For our next example, we have x squared plus x plus 4 divided by 3x squared minus 3. So when will this be restricted? Whenever 3x squared minus 3x is equal to 0. Now this is actually a 6.1b type problem because we have a greatest common factor here. Notice here we both share a 3. This has 2 x's, this has 1, so there is a greatest common factor of 3x. And we can factor that out. And that will give us 3x times whatever we need to multiply 3x by to recover 3x squared, which is just x. And then times whatever we need to multiply 3x by to get -3x would just be a -1. And that will be equal to 0. So once again, we have two factors. both of which need to be equal to 0. And that will occur when 3x is equal to 0, or x is equal to 0, or when x minus 1 is equal to 0, or when x is equal to 1. And these are the two values of x that must be excluded. Now, for my final example in this part, notice that we have 100x squared plus 35x plus 41 divided by 4. Okay, what values of x do we need to restrict? Well, notice that the denominator is 4. It's a constant value. It is not a function of x. It does not depend on x. Therefore, there are no restrictions on x. And that would be your answer. Okay, so just sit tight and let me get Hawks up and running, and we can continue on with a few more problems. Okay, so here we are. Let me go into practice here. I'm not ready to certify just yet. And here is our first problem. Find the restricted values of x for the rational expression 12x divided by 12 divided by 28x. Well, that will occur when 28x is equal to 0. When does that occur? That occurs when x is equal to 0. So we want to put in that x cannot be equal to 0 here. So we're just come over here, put in a 0, hit enter, and we're done. Okay, let's go on to another one. Here we have the expression 4x squared divided by 3x minus 7. We want to find the restricted values of x for this rational expression. Okay, well the restricted value of x are those values of x that cause 3x minus 7 to be equal to 0. Well, that is consistent with, that's the same as 3x is equal to 7, or that x is equal to 7 over 3. So this is the answer that we want to put into Hawks. So that will give us, so here we do our slash for fraction, 7, down arrow, 3, enter, there you go. Okay, for this one, we have x squared plus x plus 12 divided by the quantity 3x minus 5. Now the values of x which will be restricted here are the values that will cause the denominator go to 0, and that means to be the values of x that cause 3x squared minus 5x equal to 0. Okay, well notice here that this has a greatest common factor, and that greatest common factor happens to be equal to x. So we can actually factor this out by factoring out our greatest common factor, and that would be x. So we have x out here, and then to recover my 3x squared, I need to multiply that by 3x. And then to recover my negative 5x, I need to multiply the x by negative 5. So these are our two factors. So one factor will be x equals to 0. The other factor will be the value of x that makes this factor go to 0. And then that occurs when x is equal to negative 5 divided by 3. No, positive 5 divided by 3. My apologies. So those should be our answers. And how do I put that in? Well, I can put in my 0, comma, and then my fraction with the slash, and then put a 5 on top, a 3 on the bottom, and I should be good to go. Cool. There we go. Okay. Let's just do one more problem. Hey, let's do the last problem. And here it is. Now here we have x minus 4 divided by or negative x plus 4 divided by 13. Okay, so our denominator is 13. What value of x will make 13 0? No value of x will make 13 0. So for this particular case, there are no restrictions. We can click our no restrictions thing right here, submit our answer, and there we are. And that is all that I have for this video. As usual, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.